Hi, my name is Moises Macero. I'm the author of the book Learn Microservices with Spring Boot, and this is the book summary. Are you considering buying the book or reading it online? This video will help you. These are the main contents of the book. Big topics, take into account that the book is over 400 pages. But all these concepts are very useful nowadays. In a nutshell, you will go through a practical journey that shows how to build a microservices architecture from scratch using Spring Boot. For the readers who are not familiar with this framework, the first part of the book describes how it works. Then, the book introduces you into the world of distributed systems, focusing on microservices architectures. All of this is still supported by the practical use case. After that, you will evaluate synchronous versus asynchronous interfaces, and the system will become event-driven. Once you have the core microservices in place, you will learn all the architecture patterns that apply to distributed systems, also called cloud-native patterns. And very important in this book, you will see the problems before diving into the solutions, and you will learn how to analyze if a microservices architecture is what you need. Here is the functionality that you will build. A web application that gives you a multiplication challenge. The idea is that you solve it without using the calculator, so you train your brain a bit. You can enter your name or alias and what you think the result is. After submitting it, the app should tell you whether your guess is correct or not. In a second round, this web application implements some historical record of your previous attempts, and in a third stage, you will add some gamification to it with score, badges, and a leaderboard to encourage people to keep practicing every day. So that's how the application will evolve. First, check the result. Second, add historical records. The last part is the gamification functionality, which will actually trigger the decision to go to microservices. To fulfill the requirements of the first version of the app, you will model the user's domain and the challenges domain within a single Spring Boot application, and add the business logic to a backend that should determine if the challenges are correct. By the way, all the figures that I use in this video are real figures from the book, which contains a lot of visual help to guide you through the content. You will learn or revisit the 3-layer, 3-tier design patterns and how they relate to Spring and Spring Boot utils while you navigate through the code of the multiplication application. Anyways, to respect a practical approach and a step-by-step guidance, the book builds this application in different stages. The first stage of the development happens in Chapter 3, where the book focuses on building the domain classes, the service layer, and the controller that will expose a REST API with JSON contents. And it is precisely this REST API JSON configuration what I use to teach you how Spring Boot auto-configuration works. You will see how the Spring Boot starters and its auto-configuration classes make it possible to have so much out-of-the-box functionalities without writing any code at all. After learning this, you will no longer call this magic because you know how it works. It is important to know this since it's the only way you can adjust it for your specific use cases. At the end of the Chapter 3, we have a REST API that we can use to send multiplication attempts to a backend system. But that's not a web application, it is just a web service. So the Chapter 4 helps you build a user interface in React. It is very basic, but you will learn some core concepts of this framework. Since this is a book about microservices, I wrote it in a way so you can skip it if you're not interested in writing front-end logic. It is there only to complete the whole picture. Once you reach the end of Chapter 4, with the React frontend running, our users can start sending challenges to the backend, and therefore we have our first working version of the application. The next step, well, this app is not storing any state yet. Chapter 5 is about data. And the reason that is driving our story is that we want to add functionality to show the user the previous attempts, so they know if they are improving or they are really bad at this game. You will learn how Spring Data and the repository layer work, and how easy you can implement code to read and write to and from a database, in this case a relational database. Keep in mind that the book also teaches you the concepts and encourages you to design before you start coding. A very important topic in this chapter is, for example, the mapping between a domain model and a data model, because they don't need to be exactly the same, and actually they aren't in our use case. You will learn how to use Hibernate and JPA annotations to build a data model. Then you will see this working in practice from the database's graphical interface. The book also goes through some basic data model concepts for those who don't know them yet, like lazy loading. This chapter 5 also covers some more advanced topics about data and Spring Boot, like an analysis of how JPA, Hibernate, the database data source, and auto-configuration work together to provide such a level of abstraction that you don't even need to write a query at all, because you really need to know how all this stuff works to use it properly. The most important decision in the book's practical journey happens in Chapter 6, with the introduction of new functionality, gamification, and a hypothetical scenario where our organization wants to grow rapidly. You're confronted with the advantages, but also the disadvantages, of moving to microservices. As you can imagine, you will choose to go for microservices and implement this new feature in a different Spring Boot application. First, you will learn how a domain-driven design can help you find the boundaries between microservices and how to design the domain relationships to minimize coupling. Then, you will go through the practical journey of implementing the gamification microservice, paying special attention to the interfaces with our first microservice. To start with, these applications will communicate using a REST API. This replicates an imperative programming style across a distributed system, which is sadly a common error for many people starting with microservices. At that point, I introduce the main differences between using synchronous or asynchronous communication in distributed systems, how that leads to eventual consistency, and how this approach is possible without using an event-driven strategy yet. This is very important because you need to understand each concept separately before comprehending how these design patterns are related to each other. Chapter 7 doesn't add any new functionality to our web application, but it focuses on the problems that the synchronous dependency we developed in the previous chapter brings. Therefore, Chapter 7 is all about event-driven designs and how to implement them with a message broker. First, you will analyze the differences between having a synchronous call between microservices and using an event-driven strategy with asynchronous communication. Even though for many people having an event-driven architecture is now simply the standard, you should understand why. What problems are you solving? Do you really have these problems? In the book, I insist on challenging these fashionable architectures and looking at your specific use case to see if, for example, an event-driven design can be beneficial for you. Well, again, as you would expect from the book's title, we'll implement an event-driven design where the multiplication microservice emits an event without knowing anything about the gamification microservice at all. That's how you get loose coupling, which is one of the key aspects you should respect in a microservices architecture. Besides, I'll get into more details about how this leads to eventual consistency. For example, it might happen that the user receives the message that says that their attempt is correct, and yet their score in the gamification's leaderboard is not up to date until a few milliseconds later. The message broker I use in the book is RabbitMQ, because it allows to implement many different use cases you might encounter in real projects. Once you learn the concepts, you can use your knowledge to build the microservice interfaces using Kafka or any other popular broker. You will learn about working queues with multiple subscribers that can split the load, the overall publish-subscribe pattern, filtering, routing, etc. At a lower level, you will understand the basic semantics in RabbitMQ, topics and their respective types, queues, routing keys, binding keys, and their most important configurations. Chapter 8 is the most extensive in the book. It's 1/3 of the total pages. From the user's perspective, it adds nothing. However, it goes through the journey of making a microservices architecture ready for a real production deployment. You need to obtain scalability, proper domain isolation, fault tolerance, easy deployments, etc. If we don't implement the right architecture patterns, the decision of moving to microservices wouldn't make sense at all, because we don't get any benefit that we couldn't have achieved by just splitting the monolith in separate modules. As I told you earlier, instead of being presented with solutions, I guide you through the problems. Why do you need a certain pattern? The first challenge is about load balancing and routing from the front-end side. How does our React application know which service and what of its instances should be called? Besides, if we would add a login page, where would we put the security layer? The solution for this challenge is to introduce a new service, the gateway, which implements the pattern with the same name. This is the first of the so-called cloud-native patterns that I introduce in the book, although, apart from the fancy name, they apply to any type of distributed system. You'll see from a practical perspective how to build this gateway using a Spring Cloud Gateway and Spring Boot, and how to link it to the other microservices. With this new service in place, the front end can remain simple and talk to the backend as if it was a single service. Having solved that first challenge, we will go for the next one: how to scale up our system. After describing the problem conceptually, the book introduces the concepts of service discovery and load balancing, and guides you through a practical implementation with Consul and the Spring Cloud Console. At the end of this section, you will have the ability to balance the traffic that enters via the gateway across multiple instances of the multiplication and the gamification microservice. On the RabbitMQ side, you will see how load balancing works, applying the concepts learned in the previous chapter. Then, you will have a new question to solve: what if one of our service instances is unavailable? How should our distributed system act in this case? That's where you will learn about health checks and how Consul, as a service registry, will take care of verifying the availability and working with the gateway to only route traffic to the healthy services. To achieve this, you will of course use Spring Boot Actuator, which provides the health status in the Spring Boot apps. The next pattern I describe in the book is centralized configuration. In a microservices architecture, you will soon realize that there are cross-cutting aspects whose configuration is usually repeated in each of your microservices. This is not only inconvenient but also prone to errors if any of those configuration values change over time. To solve this, you will learn how to use Consul key value as a central configuration repository and the Spring Cloud Consul config to read it. Another common challenge in distributed systems, especially when they grow, is that logs are spread over multiple components and it's hard to find out what happens for a specific user action. Eventual consistency only makes this even harder. That's why the book describes the centralized logging pattern and distributed tracing, so you can visualize all the logs in the same place and leverage correlation identifiers to see how an original request from the user spreads across multiple services. This is great for the observability of your microservices architecture. On the practical side, you will create a simple service that collects all the logs via RabbitMQ and displays them together with their Spring Cloud Sleuth headers. You could later apply the same concepts to put these messages into Elastic Cluster with Kibana, for example. On the deployment side of the story, you see in the book how running the complete microservices system becomes more difficult as it evolves. To make it simpler, I will teach you how to use Docker containers and benefit from Docker Compose to have a single file you can use to run the system anywhere. For that purpose, you will need to learn how to create Docker images out of the microservices. The book describes how to accomplish this with build packs, introducing Spring Boot 2.3. Finally, at the end of this big chapter 8, packed with a lot of useful concepts, there is a moment to reflect at what you learned. What if all these cross-cutting architecture patterns were there out of the box, so you don't need to maintain the gateway, the service registry, the centralized logger, etc.? Well, that's actually where the cloud providers can help. At this point, you will understand the differences between the abstraction levels you can achieve by deploying a microservices architecture to the cloud. Instead of implementing and maintaining all these patterns, you can simply pay for them. But that's up to you. This chapter 8 teaches you how these patterns work, because no matter if you just pay for them, you must know what is the problem they solve and how they work if you really want to understand your microservices architecture. The last part of the book is where we look back at what we built and how we built it. This simple web application with some basic functionalities is very useful as a baseline to learn about microservices architectures, but I would never recommend you to implement an application of this size following a microservices approach if we would just stop here. So, this is somehow a reminder of the concepts introduced in Chapter 6, should you move to microservices. But it's only now when you can grasp the complexity that was described back then. Chapters 7 and 8 didn't introduce any new functionality for our users. They are all about preparing our system to be resilient, scalable, to have many people working on it at the same time with different deployable units, etc. The amount of complexity you have to deal with in a microservices architecture shouldn't be underestimated. It's up to you, with the concepts I hope you learn with this book, to make a good decision. I try to put a lot of advice that you can use, especially in Chapter 6 and in the foreword. In any case, before you go for microservices, make sure to not only read theoretical books, but get your hands dirty. That's the main reason why I wrote this book, to guide people through the experience, so they get to understand the pros and cons of microservices architectures, and they're able to build it in a step-by-step process. The book chapters are supported by code. There are different repositories in GitHub, public repositories, for each of the chapters, and even sub-chapters in case of chapter 8, which covers multiple patterns. You can also see there how I answer questions from the readers, which they can post as GitHub issues. Last but not least, the book is alive online. I already released 2 extra chapters, one about end-to-end testing with Cucumber, and a second one with the upgrade of the book Code Sources to Spring Boot 2.4, and the new major release of Spring Cloud. Well, that's all. I hope this summary was useful for you. Let me know if you still have any questions, and make sure to like this video and share it in your networks. Thanks!